So here we have the Higher 2019 Paper 1 question 13. This one here focuses on trigonometry and exact values associated with right-angled triangles. In this type of question here, you typically get given some sort of relationship between a triangle and a sine or a cosine and an angle, and what you have to do is determine accurate measurements for the sides based on that, but without obviously drawing it accurately and measuring it, and then use them in some sort of relationship relating to the question. Now this question's been nice, it's actually drawn the triangles out for you. Sometimes you'd maybe get, sine p equals 4/5, and you've got to then draw the triangle, construct the sides, and then fill in the missing gaps yourself without any assistance. This one here does that one for you. The only thing it's not done is filled in the gaps here, so this side here. Now, typically, this sort of question will ask you to then determine values for sine or cosines of angles in relation to each other and then use them as part of a calculation. This one here, it wants cos p and it wants cos q. Now remember, in order to be able to use SOHCAHTOA to get cos and sine, we have to have all three sides of the triangle completed. Now if you look at this triangle here, the triangle ABC, where the angle P exists, I've got root 5 here and I've got 1 here, but I do not have this side here. So what I've got to do is I need to use Pythagoras, because it's a right angled triangle, in order to determine this missing side here. So using Pythagoras, I know it's going to be the square root of root 5 squared take away 1 squared. So root 5 squared is 5. Take away 1 squared, that's then going to give me the square root of 4, which we should all know is 2. So this side here is 2 in this triangle. The bigger triangle, ADE, has 1 plus this side here. So this side for the full triangle, ADE, is 3. So now I have the missing sides that are associated with my question. What I can do at this point is then use SOHCAHTOA to be able to calculate what's missing and then answer the question here. So the first part is asking me for cos of p. Now using SOHCAHTOA, cos is adjacent over hypotenuse. So if I look at this triangle here, the first one, I can simply read off that cos p is adjacent over hypotenuse, so it's 2 over root 5. Similarly, I can do cos q the same way, except using the second triangle. So cos q is adjacent over hypotenuse again, but the adjacent is this full side here, which is 3. The hypotenuse is root 10. So I can simply say then for this one that cos q is equal to 3 over root 10. Then it says, hence determine the value of sine of p plus q. A key thing to look for in this sentence here is hence. Hence means use what you've just done. So this here, the cos p and the cos q, is going to come into place somewhere in this question. And even if the values were wrong, ultimately, I would still have to use the values that I had there as part of the question. Otherwise, I'm not following the hence, i.e. the use what you've just calculated. Now, value of sine of p plus q, if you look back at your formula list, you'll get all your expansions of sine of p plus or minus q and cos of p plus or minus q. And that's what we have to use here. Because I know that I can write sine of p plus q is sine p cos q plus sine q cos p. So I've got the cos q and the cos p here. That's the values I have. I need to find sine p and sine q using the triangles again. But again, I can just simply read it off from both. So if I use the first triangle that I've got there to get sine of p, so sine is opposite over hypotenuse, so that's 1 over root 5 for that one. I can then get sine q for this one, again using this triangle this time, 1 over root 10 for that. What I can then do is substitute all the values I've now got into this to determine an overall value. So sine p cos q, so sine p is 1 over root 5. Cos q is this, 3 over root 10, so that's times 3 over root 10 there, plus sine q, which is 1 over root 10, times cos p, which is 2 over root 5. What I can then do is simplify all this together. So 1 times 3 there is obviously 3. I've then got root 5 times root 10. Well, 5 times 10 is 50, so I've got square root of 50. But 50 can be split into square root of 25 times square root of 2. That then can be simplified to 5 root 2. I've then got plus 2 on the top here, and I can use the same logic at the bottom here to answer that question. So root 10 times root 5 is root 50, which is the same as root 25 times root 2, so 5 root 2 there at the bottom. So what I can then do is, now that they're common denominators, I can simply add the two fractions together. So I'll end up with 5 over 5 root 2, and then simplify it, and end up with 1 over root 2 is my value for sine of p plus q. So there you go, that's the overall solution, and I've used these two triangles to get all the parts of it in order to be able to get the answer I'm after. Now this sort of question here is 5 marks overall. First mark was for getting cos b, second mark for getting cos q. Third mark was in part B, and it was for knowing the expansion and writing it out. Fourth mark was then finding my sine p and my sine q and substituting them in. And then the fifth mark was getting to the 1 over root 2 as my final solution. Now, in this one, they would accept 5 over 5 root 2 as a solution. They would also accept if the bottom here hadn't been simplified and it was 5 over root 50. However, you would still have to simplify from here. So they wouldn't accept 5 over root 5 times root 10. The bottom still has to be combined and simplified that way. However, if you didn't cancel the 5s here, they could overlook that and they would still award you the mark for getting to this solution here. So, trig ratios and how they relate to triangles, using exact values. This sort of question here, make sure you remember the expansions for this, but just in case they are included in the formula list, enjoy.